Good morning, all. I welcome you all for the next session. I think in this session we are going to discuss about superposition theorem. I think I have to recall the previous session we are discussed about Thevenins and Nortons. So in Thevenins we are finding the V Thevenin is open circuit the load resistance. We are finding the voltage and currents Nortons we are short circuit the load resistance. We are finding the Norton's current, that is short circuit. IN is equal to ISC, and both are together. We are solving the superposition theorem. In superposition theorem, already we are know that if we are considering the current source, the voltage source will be short circuit. If you are considering voltage source, the current source will be open circuit. So when we are applying the superposition theorem is more than two sources are available in the network only we are approaching to find the total current. So first we have to consider first source. We are considering the current, finding the current is I prime, that is I1 prime, and second source will be alone. We are finding the current that we consider as the I2 prime. So finally we have to add I1 prime and I2 prime. We are getting the total current. So let's see the examples. Before that, we have to recall last sessions we are say about what is Ohm's law and independent sources, dependent sources, and difference between voltage source and the current sources, what is series and parallel circuits, and also we have to discuss today's session is a step by steps of superposition theorem and concept of the linear circuit and how to find handling the sources and the comparison of Thevenins and Nortons, and let's see the example. So here I have show you the turning of sources. Voltage source we have to short circuit. If the current source we have to open circuit. Right. And now I am considering example 1. We have to find the current. I think this circuit consists of voltage source and also current source. So first we have to consider the voltage source. So current source will be open. So that we called as the I2 current. So I2 is equal to 80 into 10 power minus 3. Why? Because 10 power minus 3 is millivolt. That is voltage source value is 80 millivolt. So 80 into 10 power minus 3 divided by these two resistors are in series. We are adding. Then I1 also we are find out the in available, that is I1 plus I2, we can get the value of minus 0.17 amps. So likewise for the example 2, in this problem we are going to find the voltage drop across 2 ohm resistor R1, and this problem also consists of voltage source and current sources. First we have to consider voltage source. So 8 ohm resistor is open circuit, and find the current V1 by R1 plus R2 R3. V1 is 20 divided by 2 plus 3 plus 5. We can find the current is 2 amps. So V1 VR1 means 2 ohm is our aim, that is load resistance. So 2 amps into 2 we can get the voltage VR1. Why? Because the ultimate aim is to find the voltage drop in the 2 ohm resistor. So first the voltage source is available, we find the VR1 is 4 volts. And for the 20 volts, we're considering 20 volts is short circuit, alive is 8 amps. So find the voltage. So for that we have to find the current. Current means this opposite resistance or resistance into voltage. So current divider law. So based on this we are finding the 4 amps, and multiple with the 2 amps is load resistor, we get the 8 volt. So VR1 is 4 volt and VR2 is 8 volt. The finally we are 12 volt flow through the resistor R1. So this is how we are finding the theorems. Here I mentioned the DT based define and empathy. And real world applications are we are using electronic circuit, communication system, power system, fault analysis, and network analysis. And here I mentioned the images also, the fault analysis and the power system analysis. And this is summary of superposition theorem lecture. And here I have mentioned a few references for your referral. So if you have any doubt, please ask. Thank you all. See you in the next session.